Hello everyone, so today I'm going to show you how to solve this very interesting problem here, which is find all real number x that satisfy this equation. X plus 2 times x plus 3 times x plus 4 times x plus 5 equals to 24. Alright, so now you notice here there are 4x, so which means when multiply together it's x to the power 4. Something x to the power 4, then x to the power 3. So it's power 4. So yes, you can actually solve this by expanding the whole of this out and then plugging it into a calculator. That works. But today I'm going to show you a really nice, clever trick that you can solve this without using any calculator. So now, first of all, you gotta know this. X plus 2, x plus 3, x plus 4, x plus 5. You gotta expand it. There's no fast way you can do this. Yes, you can factorize and put it in, but it's really hard because it's real numbers, so you have to expand it out. But you gotta notice how you expand this is important, because if you expand the wrong way, it may lead you to your solution being way longer than usual. So now, what is it? Do you notice when expanding these kind of 2 out, you get something like x squared plus ax plus, well, that's something, a random number, let's say m, right? So now you're gonna notice that ax, you see the ax is equals to these two plus together, right? For example, let's say you get these, multiply these two together. Let's say, for example, you get x squared plus 3x plus 2x, which is 5x plus 6, right? X, right? So it's these two, the sum of these two together, right? So you want this ax of when you explain both pair out to be the same. You see, 2 plus 5 is 7, and 3 plus 4 is also 7, so it's the same. And I'll show you why later that you should be the same. Alright, so you see this. Now you're going to change. You're going to move the x plus 5 here, and then you pair x plus 3 and x plus 4 here. Alright, just keep a train for there first. Now you expand these two and expand these two. You get x and then 7x and then 10, and then x squared plus 7x, same as these, plus 12, right? Plus 24. Now you got these two, and you see here, like I said before, it's the same as x squared plus ax, and you see these two are the same because we pair up such that the first two is the same. And now, well, you got this, you got plus 10 plus 12. And what do you do with this? Well, do you notice that it differs by 2 units? And well, we can actually, when you get the average of this, 10 plus 12 divided by 2, which is 11, right? And then you're gonna do this, 7 plus 11. You're gonna put this down. Actually, no. Yeah. And then you minus 1, right? And then you do the same here, but then you get 11 plus 1, right? You manipulate this such a 11 appears on both sides, and then plus 1 and minus 1. And well, what you're looking at, this is the same as a squared minus b squared. You notice that? Learn this. It's a minus b times a plus b, right? Oh, no. Well, yeah. You see, a here, and then minus b here, plus b here. See? So now we can use this, and we're gonna attach it like this. We're gonna put it like this: 7x plus 7x plus 11 square, like this, a square, and then minus minus 1 squared, which is minus 1, equals to 24. Let's delete this. Now what we got now is 11. And now we're gonna move the 24 to this side, so it became x squared minus plus 7x plus 11 whole square minus 25 equals to 0. And you notice it's also the same case. It's a squared minus b squared equal, you see, a squared b squared. This is the same as 5 squared. You see, 5 squared is 25. And I think we will write this as 5 squared, so it's easier to factorize out. So we got this 7 plus x squared plus 7 plus 11 minus 5 times x squared plus 7 plus 11 plus 5. Just like the case, like it's basically the same as this, but the same as this, but the way we do is it's the opposite. So now what we got is x squared plus 7x, 11 minus 5 is 6, and x squared plus 7x plus 16 equals to 0. And well, now we can solve for x here, because you know this is a polynomial x to the power of 2. So it's quadratic equation. And yes, you can use quadratic formula on both sides here, both of these here, and then you can find x. But I think there's a better way to do this. First, we consider this. We can factorize. Let's consider it. Let's say consider if x squared minus 7 plus 6 equals to 0. Where from experience you can see that you can factorize it as x plus 6 and x plus 1 equals to 0, which means the solution to x is equals to minus 6 and x equals to negative 1, negative 6 and negative 1, right? And now we're going to consider if this one, if assuming if x squared plus 7 plus 7x plus 16 equals to 0, right? If you try to use the quadratic formula, you see that there's no solution in this. I'll show you why. So we're gonna the fastest way to check for solution is we just complete the square. So we get this is equal to 7 divided by 2, we square up, minus 49 over 4. Yeah, and then we plus 16. This technique is called complete the square, where you get the other two plus term and you complete the square here. This will be actually equals to x times 7 times 2, which is 7x, and then plus this miscellaneous, which this extra 49 over 4 here, and then that's why we gotta cancel it out on the outside here. And well, when we add this up, 16 times 4 is 64, plus minus 49 is 15, right? It's plus 15 over 4. And do you notice, you see this, for our real number of x, this equation here is always greater or equals to x. And well, if you plus 15 over 4 here, it's always greater or equals to 15 over 4, which is always greater than 0, which means this this equation here, if it's greater than 0, it cannot be equal to 0. So cannot be equal to 0. And well, let's set this as 1, right? So this contradict with, so therefore this equation here has no solution. Has no solution. So therefore the only solution to This polynomial is x equals -6 and x equals -1. Alright, good.